a derivative measures a rate of change, and we've been using it to look at tangents and curves. But anything which we can measure and is changing, we can use this idea of calculus to find things out. So we're going to just look at this idea of rates and change in general, not necessarily curve sketching. So a block of ice in the form of a cube, guess it's an ice cube, one edge 10 centimetres long. It's melting, and its dimensions we know are decreasing at a rate of 1 millimetre per second. So that is a rate of change. But we're interested in how much volume we're losing at a particular time. So we want to know what rate that volume is going down when the edge is 5 centimetres long. So we need to come up with some sort of formula given the information that we know. That's my ice cube. I've called the side length x at any point in time. So what do I know? We're trying to find what dv dt is, the change in volume with respect to time. So how do I link volume and time together? Well, there's nothing there that will link volume and time together. However, we have got a link between the length of the edge and time. We were told that the edge is decreasing at a rate of 1 millimetre per second. So 1 millimetre, of course, is 1/10 of a centimetre. And we'll give it a negative because it's decreasing. So I could say dx dt, the rate of change of the edge length with respect to time, is -1/10. But the other link I have there is I do have a formula for volume and the length of the edge. So I could create a rate of change using calculus. If I was to differentiate v with respect to x, and I'll get 3x squared. And now I can get a formula that will link all these together using our chain rule. So dv to t would be dv dx times dx to t. And we have formulas for both of those two things. So I can now measure the rate of change of volume with respect to time. But interestingly, I don't actually need to know time. I just need to know the length of the cube to use this formula. So let's sub in. dv dx is 3x squared. dx to t is -1/10. So there's my formula, minus 3x squared on 10. Well, we're interested in when the edge is 5 centimetres long. So when x equals 5, substituting into our formula, and I get -7.5. So I know at that particular instant in time, the volume's decreasing at a rate of 7.5, and the units for volume, of course, are centimetres cubed, and it would be per second. It's our time period there. So using the idea of calculus, we can find information about how things change. How things change. Here's another one. A vessel, or it's a strange word, I think, is in the form of an inverted cone. That just means upside down. The vertical angle of the cone there, they're telling me, is 90 degrees. And they're saying if the depth of water in the vessel is X centimetres, find the volume of water first of all. So there's my inverted cone. The blue circle there is meant to represent the water level. And we know that height is X. I said the depth of the water is X. So how do I find the volume of the blue cone down the bottom here? Volume of a cone, 1/3 pi r squared h. I've got the h, I just need to work out the radius. But fortunately, that vertical angle is 90 degrees, so I could create a triangle in there, and it's going to turn out to be isosceles. Because if it's 90 degrees at the base, well, by symmetry, it must be 45. Therefore, the other angle up there would be 45. I got an isosceles triangle. The radius turns out to be the same as the height, so I know the radius for this one would also be x as well. So volume, 1/3 pi r squared h, but I now know that the radius and the height are the same. So for our problem here, the volume of the water will be 1/3 pi x cubed. So that was the first part of the question. So, water's poured in at the rate. So we're going to pour water into this vessel at a rate of 0.2 centimetres cubed per minute. Find the rate that the depth is changing when the depth gets to 4 centimetres. So, all right, we're trying to find dx to t in this case. How does the height of the water change? what sort of things do we know? They've told me in this case d to t is changing at 0.2 or 1/5. Now, the missing dimension here would be, if I can get something that links v and x together, we should be able to come up with something that links all these together. Well, volume is 1/3 pi x cubed. That was part A. So d dx is pi x squared. So now I should be able to say, okay, well, dx to t, that'll be dx to v times d to t. Dx to v would be d dx turned upside down, so 1 on pi x squared times 1/5. And that's 1 on 5 pi x squared. Okay, I got my formula. Now we just need to substitute in when x equals 4. And we get 1 on 80 pi.